want to welcome and I want to introduce to you Professor Hannah Daly, who is seated here at the front of the room, and she will be speaking to you on the topic of sustainable energy, climate change, history and future. She is the Professor of Sustainable Energy in UCC. She leads a team of researchers in UCC who look at energy systems to help reduce greenhouse gases and therefore to help bring about climate change, which we all know is really, I think most people at this stage, everybody accepts that it's an urgent matter. She is a teacher in UCC. She teaches on sustainable energy futures. She works on an introduction to energy engineering, and she speaks on energy systems and modeling. Now, if you know what that's all about, you probably have no business here. Certainly, you can share an awful lot with me because I don't, apart from some very broad general statements. Professor Hannah Daly is also a mammy, and so therefore a very busy lady indeed. Has a column on the Irish Times every month called At a Time of Crisis, and is widely used on television and abused as on matters of climate on radio and television. She's considered highly respected commentator on those topics. So without any further ado, let me introduce you to Professor Hannah Daly.
Thank you all. Good evening, and thank you for the introduction. Thanks especially to Con for the invitation. I'm very happy to be here tonight. I always really enjoy speaking about this topic that I'm very passionate about with groups of people who especially want to give up their evening to hear from someone who maybe doesn't give the cheeriest news. So as I was driving here from the city, I was thinking, okay, how will I open this? And I said, I've been abroad for a couple of years, but I'm still Irish, and I said I'd start with a few apologies. And the first apology is I've got a bit of a sore throat, and I gave my first lecture today, so hopefully I'll last the 40 minutes. The second apology is that this is, of course, a massively huge encompassing topic, and we're actually in the process of developing an undergraduate degree in UCC, which will touch on a lot of this. So if you imagine that I'm trying to compress the whole a whole undergraduate degree into 40 minutes, this will, of course, be simplifying a lot of things, and we can go into a lot of detail when we have a discussion after I talk. And then the third apology is that I remember giving a talk like this in Cork. Actually, it was the Historical and Literature Society, and the first question that I got from the floor started with, "Well, that was depressing," and I can't promise you that you won't be a bit depressed after my talk. As it was said, climate change is a really urgent crisis, and we have to be honest, we're not doing enough about it, and we're in a bad situation. And I suppose I wouldn't be honest with you if I wasn't telling you what are scientific facts, But I hope by the end, I'll just I have about 100 slides. I'm just going to cut myself off after 40 minutes. We'll see how far through the slides I get, and we'll go into the discussion. But I hope before I finish that I'll give you some sort of, I don't want to say hope, but actionable thoughts to go away with that make you think that actually this problem is actually solvable, and problems have been solved of massive magnitude. Maybe not this one, but there's something that you can actually do about it, and there's something to cling on to. I suppose finally, I'm not a historian, even though it's very nice to speak to a history group. I thought I'd pull out some of the slides that I have that really relate to the kind of history of climate change itself. Like, how do we actually know? How long have we known about the greenhouse effect, greenhouse gases? Who were the scientists that actually discovered the greenhouse effect? And then how did that translate into where we are today? What are the causes of climate change? what is the history behind those, those causes of climate change. But I'll think a lot about given what we know, given the history, given the political history, how do we move forward? And I'll give you, as you kind of go from the science and the politics and the history to the future, it gets more sort of speculative, and it gets more, I suppose, into my own personal interpretation of where we should be going. A lot of academics kind of stop at the facts, but I suppose the reason that I get asked to speak in the media is I go a little bit of a step forward and I say what I think should be done with those facts. And those are, everyone has an opinion about those things. So I'm happy to have, a robust discussion afterwards. Whatever your views on electric vehicles or meat-free diets, or we're talking about a local biogas plant, for example. It's it's an interesting thing. So I thought I'd start with actually a little-known climate scientist was actually a woman called Eunice Newton-Foote from the United States. And in 1856, she was an amateur. She didn't go to university, as women didn't at the time, but she was an amateur scientist. But she was the first scientist to confirm that some gases, atmospheric gases, warm when they're exposed to sunlight. So she had the first experimental proof that the greenhouse effect existed. And the greenhouse effect, it didn't have that name at the time, but we all kind of understand that when you're in a greenhouse, in a glass house, on a sunny day, even if it's very cold outside, whatever it is about the qualities of the glass, that it traps heat inside, it doesn't let the heat escape. So she was and some atmospheric gases that we now call greenhouse gases have that effect, that they increase the temperature of the atmosphere and affect our whole climate. So in 1856, she published a paper. She had a few glass cylinders that she evacuated the air from. She had four thermometers, and she filled one of the cylinders with water vapor, one with what was called carbonic acid at the time. Now it's known as carbon dioxide. And she showed that those containers, when they were exposed to sunlight, heated up a lot more than containers without those gases. So in fact, it was the first known publication in a scientific journal by an American woman in the field of physics. But unfortunately, she wasn't a member of the American Association of Sciences. So a man read out her paper to the annual conference. Even though this is. Anyway, so going into some more history of climate science, you might have heard of Joseph Fourier if you did anything engineering or maths or science at third level. A lot of people, Joseph Fourier founded a lot of topics of physics, number theory, quantum mechanics, weather prediction, lots of other fields. His name is on a lot of kind of aspects of maths that people will shudder at. But in the early 19th century, he's French, and he was a physicist, and he was the first to actually calculate what the average temperature of the Earth should be if you were just, because they understood the amount of energy in the sun's rays, and he understood that just based on that alone that the Earth should have been much colder. So he looked at the variations in temperature between day and night and between summer and winter, and he suggests his calculations found that the planet was much warmer than a simple analysis of incoming light would suggest. And he suggested that he predicted that somehow something in the atmosphere acted as a blanket, and as an insulator, which trapped the heat. Another name that I'd say more of you will be familiar with is John Tyndall. Gives his name to the Tyndall Institute in UCC. He was born in County Carlow, and he was a physicist who found that the key to warming was an interesting property of some atmospheric gases. And now this was before Eunice Foote, but he performed more detailed scientific analysis to show that exactly why certain gases trap heat. So they don't actually trap light, the heat from light. When light hits a dark surface, that dark surface heats up. So basically the energy that's in the light gets transformed into some heat energy. And basically the greenhouse gases in the atmosphere act as a blanket. They allow the light to pass through, but they don't allow the heat to pass through. So they basically trap heat in the atmosphere. And he showed that water vapor, carbon dioxide, and ozone are strong absorbers of that heat radiation. And he speculated how changes in water vapor and carbon dioxide could relate to climate change. So he said that the strongest effect was from water vapour, without which he said that the Earth's surface would be held fast in the iron grip of frost. And then so these scientists started to kind of understand the relationship between the ice ages and how historical climate change had affected, you know, the proliferation of species, and so on, and link that to atmospheric greenhouse gases. One final name of a scientist is Svante Arrhenius, who is a Swedish scientist, and he was the one who speculated that low CO2, so CO2 is carbon dioxide, which is now the main greenhouse gas, and that's the one kind of ominously going up here on the right. He speculated that it was low CO2 levels that caused the ice ages. And actually, some of them also understood that at different times in the Earth's history, there was a lot more CO2 in the atmosphere, and that caused a lot more plant growth, and this was actually caused the coal beds to be laid down. So the reason that we actually have fossil fuels, coal, oil and gas and peat, is because of plant material, like very, very long ago in history. And he actually suggested, he calculated that a doubling of the amount of CO2 in the atmosphere, what we call the CO2 concentration, would lead to a 5-degree temperature rise, which is actually confirmed by modern science. So that is, I think that is that's really interesting. After these, you know, the topic was forgotten for a very long time because it was kind of interesting theoretically, but the variations in the sun's rays and water vapor and different natural forces of climate change, I suppose, would have been much bigger, larger in the magnitude than the humans' action on the climate. But what none of these people foresaw was how fast and how far the use of fossil fuels and industrial agriculture would grow. See this chart here. So they were discovering kind of these effects when our main energy source was coal, and actually biomass as well from trees, and it has really grown exponentially since then. And by 1950, industrial emissions were about 3 times as much as in 1900, and now they're about 20 times that much. So now, this is not really a theoretical exercise, it's really something that is starting to affect us. And in fact, this is an interesting newspaper clipping that I saw in 1912 from a newspaper clipping, the coal consumption affecting climate. So the furnaces of the world are now burning about 2 billion tons of coal a year, and when this is buried, united with oxygen, it adds about 7 billion tons of carbon dioxide to the atmosphere. This tends to make the air a more effective blanket for the Earth. That's not me, is it?
No.
Oh.
Sorry, can I just deal with that?
That's fine.
You continue at your talk.
That's fine. And it said that this tends to make the air a more effective blanket for the Earth and to raise its temperature, and the Earth this effect may be considerable.
Sorry for that interruption now.
So I suppose, like where we are today now, that's the history bit over, I'm afraid. We're really in uncharted territory now, and here's another few kind of, I suppose, historical graphs. And this is, I suppose, a bit more history. That this is the concentration of CO2 in the atmosphere. So this is how much, like if you take, a kilo of atmospheric gases, what concentration carbon dioxide is in there. And this shows the interglacial periods, so when the Earth was warmer. And you can see that, we have ice core records. So Arctic scientists would have drilled down into these, miles deep glaciers in the Antarctic and Greenland, and actually analysed the composition of the gases trapped in air bubbles, and seen that, what was the concentration of CO2 and different greenhouse gases at, very, very long history. So we actually have a very long scientific record of atmospheric CO2 concentrations, and it rose and it fell according to the ice ages. And this is just I won't pretend to be a geologist or to be able to explain this, but you can see that like the warm interglacial periods are related to increased CO2 emissions. So effectively, CO2, which is now the main lever that we have to explain CO2 emissions, you can think of it as very small. It's about 300. It's now around 420 parts per million. Very, very small concentration of this in the atmosphere. But I see it as a little bit like a thermostat in the corner of a room that is very, very related to the average temperature. So CO2 concentrations go up, average temperature goes up. CO2 concentrations go down, average temperature goes down, and that's where kind of the Earth is a dynamic system where this has been in flux throughout all of history, even pre-human history. But humans evolved in this period. So when CO2 concentrations were relatively stable and relatively low, actually. So this is where our agriculture systems evolved, our infrastructure and our societies. And now we have increased, through human activities, we've increased the concentration of CO2 in the atmosphere well above the levels in hundreds of thousands of years, possibly even millions of years. So well before our species, evolved and was developed modern agriculture and modern societies. So this is, and it's still rising. So actually, this chart, I'd say I took this from about 4 years ago, maybe, but that's still going up very sharply. We've been measuring CO2 concentrations directly in the atmosphere since around the 1950s, and there's kind of cycles annually. It's going up, and that's well out of date. Methane emissions is the second most important human forcer of climate change. There was a pause, but now that's accelerating again. And nitrous oxide, which comes from different sources, is the third most. So the last time CO2 concentrations were this high was around 3 million years ago, some scientists speculate. And at that time, there was forests at the South Pole. The sea levels were 15 to 20 meters higher than they are now. And the world was 3 to 4 degrees warmer. So this was a world almost without ice, if you can imagine what that would mean. And it's not just the scale of the I suppose the amount of CO2 in the atmosphere, it is also the speed at which this is changing. So it's changing at an unprecedented speed. So I told you this would be depressing. I have some memes later on to lighten it up, but I'm not sure that it is necessarily it is a depressing subject. So this is CO2 concentrations for the last 2,000 years approximately. So you can't see the axis there, but what we call pre-industrial CO2 concentrations is about 280 parts per million. It's quite steady, and at the foundation of the Irish state in 1923 was around 304 parts per million. So it had already risen because of the Industrial Revolution, because we're basically started using coal, and now in 2025 it's 427 parts per million. So it's risen by around 40%. I'm sure that's some people here. You can see what it would be over your lifetimes. I was born around here. My kids were born here, and it's really stark to think how much this has changed over one lifetime. This is just one lifetime. How this has changed so rapidly. So it's an understatement to say that we're in uncharted territory. So the rate of rise, I'm just looking at my notes, is even more striking. It's the fastest rate of rise for 66 million years. And the impacts are already being felt, as we can see in Los Angeles at the moment, Valencia last year. So this is again just more charts. So I'll stop with the charts soon. So a few days ago, some of the main climate science groups released their assessment of 2024, and NASA, Hadley Center, NOAA, which is the North American Ocean and Atmospheric Association, Berkeley, Copernicus, which is the European Climate Observatory, they all released their assessments about what was 2024, and they all concluded basically that last year average temperatures were above 1.5 degrees above pre-industrial temperatures. So it seems like 1.5 degrees. It's the agreement, this benchmark that this political agreement from 2015, from the Paris Agreement. It doesn't seem like it's a lot of, you wouldn't really notice the difference between now, like 1.5 degree temperature rise. But imagine what it takes to kind of boil your small kettle of water, the amount of electricity that it takes to boil your kettle of water. Now imagine boiling a kettle of water, warming the whole of the earth, all of the water and all of the air, the whole of the planet by 1.5 degrees, and how much extra energy that has. You know, you can think of our climate system. It runs on heat, and when we're adding more energy to that climate system, it causes more extreme temperatures, and it causes basically the climate that we have taken for granted as being very stable to shift out of these stable systems. And that's why we're seeing weird weather, we're seeing more climate damages, and we're seeing people suffer as a result. And that's just going to get worse as we keep putting greenhouse gases into the atmosphere. Here there's lots of small kind of writing here, so don't try to read this, but this is just a snapshot, again, from that assessment of 2024, that kind of tries to capture this, because I think we kind of see lots of these things flash by in the news and headlines, but when you put them all together, it really shows a stark story of what's happening, you know. I'll just pick out a small few and read them out. So for example, last year, this is all 2024, Europe had its warmest year on record. Actually, every continent apart from Australia, I think, had their warmest year in recorded history. In 2024, the Arctic minimum sea ice extent was the 7th smallest on record. So, scientists, oceanographers believe that we've now locked in summers without any sea ice in the Antarctic, because I suppose the ice is really the canary in the coal mine when you think of heat. In Spain, a historic deluge of rain in southern Spain in late October caused catastrophic destruction and more than 200 deaths in the area of Valencia. Warmer air can contain more moisture, and then it falls more intensely, and it also causes droughts. Basically, it causes more extreme of droughts, which cause more parched land. It makes land more susceptible to flooding, and then it all comes down at once, and you see what happened in Valencia. Persian Gulf, an extreme rainstorm in April brought 2 years of precipitation in 24 hours. So we're seeing extreme rain. North Indian Ocean cyclone, much below average activity, so 4 storms including 1 cyclone. So you're seeing shifts in cyclone activity, which is affecting crop prediction and so on. So severe droughts in South America. Hurricane Helene, an Atlantic hurricane. It was the deadliest hurricane to affect the US since Hurricane Katrina, with 219 fatalities. And now, you can't say with certainty how much climate change affected each one of these events. So there's natural variabilities. There's, a lot of these are maybe 1 in 100 year, 1 in 500 year events. But now there's a new science called climate attribution studies. So climate modelers will run simulations of weather in a particular system, hundreds of millions of times, just to simulate how likely it is that a given event would have happened with and without the effect of increased greenhouse gases. And we can see, now we can kind of scientifically say how more likely climate change made these events. It puts its thumb on the scale of how likely some things would happen. So you're getting 1 in 100 year events changing into 1 in 10 year events, and far more likely these events. I mean, this is really, LA is burning right now. I mean, it's really something out of a horror movie. I'm sure you agree. Again, we don't know exactly what climate change has caused, but it's certainly, like, LA has had historic droughts. And of course it's kind of tied up with forest management and so on. Here's a picture from Valencia, again, which we all know was really devastating. So, I suppose two words that strike fear into the heart of people who think about this often as well is something called tipping points. And it's not just about kind of increasing extreme kind of weather events, but climate change can cause kind of permanent destabilizing effects in some systems. And I'm sure many of you have heard of the risk that's now becoming more prominent in the media, is the risk of a shutdown of a very important system in the North Atlantic Gulf Stream called the AMOC, the Atlantic Meridional Oscillating Current. So it's the system that basically gives Ireland a warmer climate that brings heat from the Gulf to Ireland, and then brings recycles nutrients back to the Atlantic. So there's the Atlantic Meridional Overturning Circulation collapse. So this is basically a system that circulates heat and minerals and nutrients throughout the Atlantic. And because we know that Greenland is dumping loads of cold fresh water, it's been speculated, and there's some evidence to show that that whole system is slowing down, and it has shut down in the past very rapidly. And some, I suppose, more what are scary predictions are showing that it's likely that, quite possible, that this system will shut down this century, by 2050, which would make Ireland's climate more like northern Norway, which would have a massive change, of course, in our infrastructure and on our agriculture systems. So these are not kind of still speculative things. There's scientists working on these. This is on top of things like sea level rise and extreme weather. So there's about 13 tipping points that are likely or possible if we get to about 2.5 degrees of warming. So it's about I suppose what someone would say poking a sleeping lion with a short stick. That's what we're doing. We're really so that's a bit about like what the impacts, how serious this is. And now I want to talk a bit about the causes of climate change. So which is I suppose my main area of expertise is the energy system, is especially Ireland's energy system I focus, but I've also looked at, worked at the global level in the UK as well, because our energy system is our main source of global greenhouse gas emissions, mainly carbon dioxide. So energy there, that is energy that we use in buildings to heat our buildings. In Ireland, we use an awful lot of oil, coal, peat and gas to heat our buildings. We have the most fossil fuel dependent building heating systems, I suppose, in Europe. And we have very also leaky buildings. So like all the heat that we produce basically gets wasted because it leaks out. So that's buildings there at 17.5% globally. Transport, cars, trucks and planes run on internal combustion engines largely that use oil, 16%. And then energy use in industry, smaller share in Ireland because we don't really have heavy industry, but basically the materials that we use to build, construct our cities and our towns and our roads, iron and steel, cement, plastics and chemicals, and food, another about a quarter. And of course a lot of that is overseas and we import that. And then there's different kind of emissions from energy production, kind of leakage and so on. Electricity generation is actually in there, but it's counted for in the sectors where it's used. So in buildings and so on, electricity is a huge amount. Agriculture, forestry and land use, here the direct emissions are about 18%. If you kind of add the energy related emissions that are to do with producing and consuming food, you'd get to more like 25 or 30%. So actually the food that we eat is a major source of greenhouse gas emissions, as well as other environmental impacts. And then a small amount from industry, so cement, that's sort of non-CO2 gases. So in Ireland, the picture looks a bit different. We have around half of our emissions come from energy, and another half come from a mixture of our agriculture, so livestock, and land use, so degraded peat soils. And actually some of our forests are net emitters of climate change, which is, I was horrified to find out, because we shouldn't be planting forests on peatland. So this is what, this is my main bread and butter, is producing scenarios of the future greenhouse gas emissions and showing how policies that are enacted by governments and new technologies would change, would bend the curve. So remember during COVID we were talking about bending the curve, so about how different policies would affect greenhouse gas emissions. Sorry, this is you've got an axis cut off here, but we know energy modelers who I work with can produce scenarios of the future that are consistent with their political commitments. So limiting warming to 1.5 degrees Celsius, so you're not going past these tipping points. And I should actually pause there and say that the 1.5 degree threshold that we passed last year, that is hopefully temporary. So there are kind of natural variations. So that might come back down to 1.4 this year, or 1.3. And like the political commitment is a long-term, like 10 to 20-year average. So we haven't we won't say that we crossed the Paris Agreement threshold permanently yet. These are the scenarios that climate scientists think are enough to limit warming to 1.5 degree, and that means actually getting to negative emissions. I know it kind of sounds like an oxymoron, but we're drawing down more carbon from the atmosphere than we're emitting around after 2050 and getting to what we call net zero. And that's why we have this target of net zero front in mind. The sooner that we get to zero, so where emissions of greenhouse gases are balanced by removals, that it's at that point that the problem stops getting worse. So you have to appreciate the cumulative nature of CO2 in the atmosphere. Once you emit it, it stays there unless you actively take it out again. But unfortunately, the implemented policies, if you go to every country and you look at the policies that they've put in place, their plans for building fossil fuel infrastructure, their plans for their agriculture sector and deforestation, you don't get to a sort of reduction in CO2 emissions. This is a particularly pessimistic one. Some of the different organisations would say would predict a peaking in fossil fuel use and a slow decline in greenhouse gas emissions. But just a decline is not enough. You need to get to zero before the problem gets worse. So current policies are leading us to around 3 degrees of warming. That sounds bad, and it is, but before the Paris Agreement in 2015, these projections would have shown that we were on track to 5 degrees of warming. So we are bending the curve, just not quickly enough. And now I just want to maybe do a survey and say, did anyone see the movie Don't Look Up? Did you see the... Yeah, okay. Maybe more, maybe wrong crowd for Don't Look Up, but it's a great allegory for climate change. As some of you saw it, and it was very cathartic if you go on to Netflix, I think it's still on Netflix, and watch it. The allegory is that there's a giant comet that's heading for Earth, and there's a bunch of scientists who are trying to point out to the politicians and to the media and to the public that there's a really big problem, and we really need to do something about this, And here, there's just this great scene where Leonardo DiCaprio is speaking. This is the advisor to the President of the United States, who's played by Meryl Streep. It's very good, and he's just like, I'm just trying to explain the science, not trying to be crazy or anything. And he's just like, I know, but this is just so stressful. And there was actually a great quote that was reported in the media this week that I said, I'm using this in every talk in the future, that the problem is so big that even describing it factually sounds like scaremongering. So I haven't told you anything that isn't basically dry science yet, but it sounds like I'm a bit crazy, doesn't it? And this is because it's just so big. This is actually said by a High Court judge this week when he quashed the refusal of planning permission to a wind farm from on board Planola because the planners basically didn't. They took the visual impact of wind turbines as being much more important than a habitable planet. So just trying to take a light note, but it's probably not working. I'll talk a little bit about the political response to climate change and just going back again, a little bit more history. So I suppose there was a report to the America's Presidential Science Advisory Committee in 1965, which outlined all the physics and what we know about climate change. This could be here was a model in 1974 which predicted future warming, and that's matched against warming that actually occurred. The first World Climate Conference in 1979 convened in Geneva at the World Meteorological Organization, and the declaration coming from that conference was, having regard to the all-pervasive influence of climate on human society and on many fields of human activities and endeavour, the conference finds that it is now urgently necessary for the nations of the world to take full advantage of man's present knowledge of climate, to take steps to improve significantly that knowledge, do more research, all scientists will say that, but also to foresee and prevent potential man-made changes in climate that might be adverse to the well-being of humanity. So you can kind of point that, we had scientific knowledge and we had political knowledge, and we had political consensus going back to the 70s, 60s, 50s, and even back to the 1900s. And we're still kind of not doing enough about it. We have the Intergovernmental Panel on Climate Change that was established following that WMO conference, and the UN Environmental Programme, which is an intergovernmentally supervised expert assessment mechanism. It's a way of assessing the science that's known, the impacts and adaptation and vulnerability to climate change, and mitigation. So mitigation is solving, basically cutting greenhouse gas emissions. And the latest, you might have heard in 2022-23, the latest assessment report kind of established that, I suppose I have some quotes from the fifth assessment report in 2014, but it found was this that all the science is saying that warming of the climate system is unequivocal, that it is extremely likely to be caused by people's activities. That has now switched to certainly caused by people's activities, we know for certainly, and that continued emissions increase the likelihood of severe, pervasive and irreversible impacts. And future emissions and warming depend on policy and development. It depends on what we do from now on. We always have agency over the future, and I suppose that the most significant political kind of commitment was the Paris Agreement in 2015. So 196 state parties in Paris in COP21 was adopted on December 12th, where every country signed an agreement which included lots of different aspects, but the core one was to prevent dangerous changes on the climate, to limit global warming to well below 2 degrees Celsius, and to strive to keep that to 1.5 degrees. So this well below 2 degrees is the firm commitment, and then there's an aspirational 1.5 degrees, and then there's a process of countries submitting commitments and policies. I'll talk a bit about Ireland now and where we are. So we now have a legally binding carbon budget framework, which is under law supposed to be consistent with the Paris Agreement. We emit around about 60 million tonnes of carbon dioxide emissions every year, equivalent if you add all the greenhouse gases up and kind of make them equivalent to CO2, that's what we get. So during the COVID-19 pandemic, there was around a 4% fall in greenhouse gases as we stopped travelling and stopped flying. But that rebounded. I don't have this update. We're a small country, but we actually have a large per capita impact. We're the second largest per capita emitter in Europe. We're highly dependent on fossil fuels, and we missed various chances throughout history through energy crises to transform our energy system to be more efficient and to be less dependent on fossil fuels. I'll tell you a bit about my grandfather from Limerick City. He was a plumber in the 60s and 70s, and then in the 70s when there was strikes at the cement factory, he went out on his own and he installed back boilers into people's houses. He did a bit of digging, and actually the government was giving grants for people to install back boilers as a response to the 1970s oil crisis. So that is so people could heat their homes with turf, with coal and with logs, to give people a bit of energy security and protect them from the oil crisis. If you look at the Scandinavian countries, a lot of European countries, they started building homes to be much better insulated. They built heat networks.
Different climate though.
Heat networks. They also, they heated their homes with kind of more sustainable fuels. So in Ireland now we have to do that. Kind of going forward, we missed that opportunity in the 70s to do that. So we committed to basically these two carbon budgets. You might have heard of carbon budgets. The reason that we have carbon budgets is that rather than just a net zero by 2050 target, is because it's the cumulative. It's the addition of all the carbon emissions that you put to the atmosphere that matter. So these are three illustrative pathways. They all get to net zero by 2050. But the one on the left, where you do early steep reductions, has about half of the warming impact as the late action one, because the cumulative emissions, the area under the curve, is about half. I'll speed up a little bit because I do want to get to the solutions. And I suppose the good news is that the technologies to develop the steep early mitigation that is required, to get to the 1.5 degree target, the technologies and solutions are already available, and they're largely cost effective and bring broader benefits. Okay, so this is not, there are of course technological and financing hurdles, but these hurdles are surmountable. So this is a positive story. So I want to talk about the 5 measures that take us 90% of the way to our 2030 objectives. This is focusing on energy, on heat, electricity, transport, and so on, which is my area of expertise. Agriculture is a whole other story. We could do another night on agriculture, I'm sure. But the most important measure is to replace the primary source of energy that we use, from fossil fuels, which are mainly imported, to wind, solar, and an expanded electricity grid. This is the raw energy that we need to power our energy system. The second measure is to electrify transport. So that's electric vehicles, electric bikes, electric trucks. Okay, these technologies already exist and and bring a lot of benefits. The third is to reduce unnecessary car use. Technology alone is not enough. Technology is great, but alone it won't bring us far enough the way, and we won't be able to benefit from reducing congestion, healthier cities and towns, and improving people's accessibility. So you want to also reduce unnecessary car use by building better public transport, especially in cities. So many people in Dublin and Cork City have to have a car because public transport is so poor and because the streets are so dangerous for cyclists. The fourth is clean heat. 12% of our emission savings will come from clean heat. Heat pumps, retrofitting, and clean heat networks. You might hear about district heating networks. In towns like Macroom, it'll make the air cleaner, and it'll make homes warmer, it'll make homes healthier. And the final is to decarbonise industry, so to find solutions for our dairy processing, for cement manufacture, Hanish Alumina are all trying to figure out how to convert their energy processing, their processing and manufacturing capacity to work mainly on electricity, but in some cases also on hydrogen or biogas. So that's basically the big five, and I've written a bit about this, about this is what we need to aim all of the public policy towards. Don't get distracted by hydrogen, don't get distracted by nuclear. All of these are, gets us 90% of the way, and it's good. So the status quo is hugely costly. I think I'll skip through this a bit, but the energy transition brings many benefits, not just a safe climate, but our current energy system makes us very insecure. It makes us vulnerable because we're so dependent on imported gas and oil, for example. This is the reason why we faced hardship after Russia's invasion of Ukraine, and which caused massive spikes in energy prices. So that was really a fossil fuel crisis that caused hardship. It wasn't, all the inflation that came about in the last couple of years is because fossil fuels play such a big role, and because they're very geopolitically insecure. So when we convert to having an efficient energy system where all the primary energy is made in Ireland, and it's more clean, it runs cheaper, we'll be far less vulnerable to those impacts. Health, well-being, and equality, you can feel it on cold nights in Macroom like this, burning coal and peat, especially in homes. It's often the only way that people can heat their homes affordably, but it also causes very bad lung disease. An estimated 1,000 people die prematurely every year because of air pollution, also because of the traffic. But also we have large rates of energy poverty, so this is a very unequal energy system as well. And finally, prosperity, so there's lots of opportunities in the clean energy transition. So, we can realise the benefits of this by accelerating clean energy, cutting fossil fuels, and managing energy demand. I want to kind of make sure we have time for the Q&A, so I'll skip to this. So I like this. This is one of my favourite cartoons. It's this Speed Climate Summit, and this guy here is saying, energy independence, preserve the rainforest, sustainability, green jobs, livable cities, clean air and water, healthy children. And this guy is saying, what if it's all a big hoax and we create a better future for nothing? These are all things that you would want to do anyway, I suppose, is the point here. It's interesting that this cartoon is quite old, and you hear very little actual outright climate denial anymore. What we're moving from is denial of the problem to obfuscation and creating doubt and sowing doubt and confusion and, I suppose, infighting over the solutions. So we're getting, there's loads of disinformation out there about the clean energy solutions, lots of false solutions being put out there, and that's, I suppose, what I try to focus in my public communication on that. So I'll throw this question out there. We've understood the science for more than 100 years. We have broad political and societal consensus for the need to act. There's very few climate deniers in Ireland. If you ask even Fianna Fáil, Fine Gael and independent voters, they'll all say that the next government should actually be doing more on climate than the previous government. So for every 4 Fianna Fáil voters for every 1 Fianna Fáil voter who says the government should be doing less on climate, there are 4 that says that we should be doing more. So this is not there's no rural-urban divide here. There's a large consensus politically and societally on the need to act, and we have the technologies to cause deep cuts in greenhouse gas emissions. They're largely cost-effective and they bring benefits. But what is stopping us from acting? So I think I have a few more slides with my theories about what's stopping us from acting, but maybe I'll leave it to you and we, to the discussion. So I know this has been a heavy night, and I encourage you all after this, you have a good hearty discussion, I'm sure. Go home and do what I do when I kind of have a hard time of thinking about contemplating the future. Go and have a hot chocolate or a nice glass of wine and pet the dog and play with your kids, And then tomorrow, think about, contact SEAI, can you get a few grants for retrofitting the house? Think about getting an electric bike or an electric car. think about if you can afford it, or ask why is there no safe footpath? You know, can you kind of contact a local councillor or politician to you know, use your time and use your energy to kind of look at what's stopping us, and how can you move forward? You know, get books from the library on this issue to look it up, because I think that, you know, it's very painful. It's kind of hard to realise this, but I think like it's not going to go away. It's only going to get worse, and I think you get a lot more feeling of satisfaction from kind of participating in the solutions, of which there are very many, and many people are working on this. This is why I can give up my Tuesday night to come talk to groups like this, and I hope that, you know, through the seeds of many different changes, that there will be a kind of a positive tipping point, where people come together and actually realise the solutions, because we have it here, and you know, there's lots of examples throughout history of things that seemed very bad. You know, you're talking nuclear winter, acid rain, you know, things like that, where things did get better because of people and because of science. So yeah, I'll leave it there so we have time for discussion, but hope you had some food for thought from that. Thanks. I will.
So thank you very much indeed, Professor Daly. My goodness me. You did mention depressing at the start. I also felt a bit scary there while some of that information was coming out to us. And I suppose the scariest thing of all really about it is that science is an absolute. It's empirical evidence. There's no denying science. That is proven. So we have to face up to truths, I suppose, when they're put before us. I certainly think that it's great that people are thinking about this, that people are putting arguments forward on all sides of it, and it's only really through discussion and debate that we're going to arrive at a place which is the right place to be. Now,
exactly.
Can we just maybe wrap it up at this stage? I have to say my own statement of the kind of the elephant in the room is, which hasn't been mentioned, is aviation. I noticed there was a 19% up there when we were comparing the figures in Ireland, 19% on carbon problems, and I mean, agriculture wasn't all that far ahead of it. It was 20-something%.
Yeah.
And somehow or another, nobody anywhere that I have come across says anything about cutting back flights.
Yeah, I have a column on that.
There's one.
Oh, there's a lot on aviation. Yeah,
I mean,
because
we certainly seem to have got to the stage where people are hopping on a flight for the weekend, going down to the Canary Islands or going down to the south of France and coming back up again for Monday morning's work. And one wonders about that kind of practice. Look, I love it myself, and I'd love to be able to do it.
Do what I say and not as I do.
But honest to goodness, like, I think these short hops really is something that I'd like to. Look, we've had a most wonderfully stimulating evening. At first, I have to say, Professor, that I thought I was going to get lost in all your wonderful graphs, and I thought to myself, where is this going? But as it went on, it became more and more riveting, and very compulsive listening. I have to say, I certainly found it like that. Now, there are 2 or 3 things we must do at this stage. First of all, we are going to say a very big thank you to you for coming along again this evening. It's been tremendous. And